Welcome to our next lesson on interior and central angles. We're going to start off by looking at the definition of an interior angle. So on the right hand side here, we have a diagram of a triangle and a little extended line. Now the interior angle is going to be the inside of the polygon, which is our triangle, and that's 30 degrees. Anything on the outside of that is called the exterior angle. So this 150 is an exterior angle that's on the outside of our polygon. So then when we write the definition of our interior angle, we're just going to say it is the angle in the inside of a polygon. So here are some formulas about our interior angles. We know that the sum of the interior angles in a polygon is calculated as 180 times n minus 2, where n is the number of interior angles. The other formula is the size of each interior angle can be calculated as 180 times n minus 2 divided by n. Now this one is only good for regular polygons, and that's the only time you can really use it, because this means that every single angle is going to be the same in that polygon. This one doesn't matter, it can be for any polygon. So let's look at examples of how we can use these two formulas. I want to find the interior angle of a triangle. Well, we already know from our very last unit in trigonometry that if we add the three angles together, we are going to get 180 degrees in a triangle. So to find the missing one, I'm going to call this x. We just are going to take the 180, which is the total sum of all the angles in a triangle, and then subtract out the other two that were given to us, and whatever's left over is going to be that last angle. So this is 46 degrees. So x is 46 degrees. In the next example, we want to find the fourth interior angle of a quadrilateral. Now, if you didn't know that the sum of the interior angles of a quadrilateral is 360, you can definitely calculate that. So we're going to do that first, just in case you didn't know. We're going to use a formula that was given to us up here. The sum of the interior angles is 180 times n minus 2. So we can tell that we have four angles in here, 1, 2, 3, 4, missing one. We can just call that x. So then that means that n is 4. 4 minus 2 is 2, so we're going to do 180 times 2, which is 360. And this just verifies that we know that the sum of the interior angles of a four-sided polygon, which is our quadrilateral, is 360 degrees. All right, then our next step is just to find x. And we can do that with a similar method as the previous example, where we take the total sum of the interior angles and then subtract the other angles that we already know. So the three that we know are 82 degrees, 113, and 51. So after we subtract those, we're going to get 114 degrees. Moving on to the next example. In this case, we have a pentagon. So that is a five-sided shape. We want to find the angle x, which is this one in here. We're going to follow the same steps as the previous example. I'm going to find the sum of the interior angles first, so I know how much it would all add up to, and then we'll find our missing angle x. So our formula to find the sum of the interior angles is 180 n minus 2, where n is the number of angles, and we have 5 angles in this case. Then 180 times 3, which is 540 degrees. So what we just found is the sum of the interior angles. So if I were to add up all these angles inside our pentagon, we're going to get 540. My next step is to find x. So we're going to take the 540 and then subtract the 4 other angles that we were given, which is 58, 100, 112, and 25. Our missing angle is going to be 245 degrees. Moving on to our next example, we just want to find the sum of the interior angles in a regular hexagon. So a hexagon has 6 sides, which means it has 6 angles. So that means our n is going to be 6. 6 minus 2 is 4, and then 180 times 4 is 720. So the sum of the interior angles of a hexagon is 720 degrees. Our last example for our interior angles, we want to calculate the size of each interior angle in a regular octagon. So looking back at our second formula, this is the size of each interior angle is 180 times n minus 2 divided by n. And this occurs for regular polygons, and we're looking at a regular octagon. So this formula would work for us. An octagon has 8 sides, which means it also has 8 angles. So the size of each interior angle is calculated as 180 times n minus 2 divided by n. In this case, our n is 8. Eight minus 2 is 6. So what I'm going to put in the calculator then is 180 times 6 first, which is 1080, and then divided by 8. That's 135 degrees. So that means each interior angle in an octagon is 135 degrees. Looking at our next definition, this is on central angles. So the central angle is an angle made at the center of the polygon by 2 adjacent vertices of the polygon. So our example for this polygon is this central angle that's on the inside there. And it's made by 2 adjacent vertices. So the vertice just means that it's going to connect with a point, a corner, like that on the polygon. So all central angles are going to add up to 360 degrees, which is a full circle. It makes sense. So again, if I were to erase this and show you, it's just saying that your central angle, if we add them all up, we're going to go a full 360 like that. So that means the central angle is 360 divided by the number of sides, because they're all going to have to be equal to each other, especially at vertices. So that means if I keep breaking up to chunks like this, going to each of the vertices of our polygon, all these angles in here are equal to each other. And we can find that central angle by using this formula, 360 divided by n, where n is the number of sides. So let's go ahead and do some examples of this. Determine the measure of a central angle of a regular quadrilateral. A quadrilateral has 4 sides. So if you're going to look for the central angle, it's going to be 360 divided by n. But in this case, our n is 4, which is 90 degrees. Moving on to the next example, we're looking at a regular decagon. So a decagon has 10 sides. I am not going to draw this one. That's a little too hard for me. But I can definitely find the central angle of a decagon. It's going to be calculated as 360 divided by the number of sides. We have 10 sides in a decagon. That's 36 degrees for each angle in each central angle in a regular decagon. For our last example here, we have a regular polygon. We already know that the central angle is 45 degrees, and we want to find the number of sides. We are going to use the same formula. The central angle is 360 divided by n. But we know what the central angle is, so I'm just going to replace the central angle with 45 degrees. And now we have an equation where we can solve for n. So what am I going to do? I'm going to put this over 1 so I can cross multiply and divide to solve for n. And we can do that because 45 divided by 1 is still 45. Okay, so when I cross multiply, it'd be 45 times n, so 45n. 360 multiplied by 1 is still 360. And then I'm going to divide both sides by 45. So 360 divided by 45 is 8. This means that our polygon has 8 sides.